Welcome to today's webinar on Istio. With a special guest today, we have Shriram from IBM, who is one of the team leads on the Istio project, as well as your Tigera host, Christopher Lewin-Stolpe. So Shriram, I'd love to start with you, just to understand better what Istio is, why we'd want to use it, and of course what you get from Istio, and then I'll let you and Christopher take it from there.
You would get things such as circuit breakers, rate limits, retries, timeouts, and so on. And communications will be automatically upgraded to HTTP2, which provides like a lot more efficiency on top of things. You can do a whole lot of cool things such as like A/B testing, canary rollouts, and incremental deployments. And on top of this, you get a very nice programmable fabric on top of which you can impose a whole set of like policies such as like rate limits, quotas, access controls, and so on. And so essentially you can imagine this as sort of a layer 7, what do you call it, interconnect for your microservices, where you can actually like view your entire fleet of services as one whole unit on which you can actually impose a set of like controls and reason about the entire end-to-end infrastructure.
Okay, I think that was a pretty good synopsis. I guess I'll now talk about maybe how it fits as part of a broader picture within a microservices deployment infrastructure like Kubernetes. So if you look at Kubernetes, Kubernetes does a number of things. And that includes orchestration, workload placement, scheduling, resiliency, auto scaling, etc. It also, though, has lots of plugins. There's lots of things that Kubernetes by itself does not do. And one of those things is an area that we've taken to calling application connectivity. And that's across the line from networking all the way up to as Shriram said, L7. There are some basic primitives in Kubernetes that do some of those functions, say proxy, etc., or kubedns. But really, the design always was that those should be extendable and more feature-rich capabilities be brought into it. So if I take a look at this stack, Istio can do a lot of things along the application connectivity stack, but it's really focused, as Shriram said, on application layer connectivity. So that L5 through 7, that HTTP flow, that gRPC flow, potentially other kinds of applications as well, and manipulating those flows based on the information available at those layers. So what is the URI that's being accessed, or what is the action that's being requested across that URI. There's another component to this, though, is that you still need to get traffic between the Istio endpoints or the Istio-enabled endpoints. So one of the things you still need is some form of network and some form of network policy control. And this is where actually we're getting interested in this from a Tigera standpoint, is you still need the network, you still need the network policy, but it's also useful to have policy at a higher layer, right? There's no one single place where policies should be appropriately delivered. So when we look at something like Istio, what we see at Tigera is the ability to extend policy and connectivity all the way up to L7. So starting with the building blocks that we have, say with Project Calico and L3 and L4, and then building on top of that with L5 through 7 capability with and I guess, Shriram, what's your view? You guys have done some deployments in IBM with Kubernetes networking and Istio. How do you guys see how these capabilities balance out and how they fit together?
Yeah, so that's a good question. From what we actually see, people typically tend to it's right now the space is sort of fractured, where you have to go and secure your network infrastructure via like something like Calico, and then you also go and set up your policies at the application level for like, let's say, authorization, access control, and so on and so forth. And it is, I mean, people have basically expressed interest that we would like to have a single pane of glass through which we can actually like, deliver these policies and impose a whole lot of like role-based access control like mechanisms to ensure that like, only certain operators can devise these policies or execute these policies. And to them, they don't really care as to like, they don't really want to go to 10 different points in the infrastructure to actually like set up their secure the system for that matter. They just want one single pane of glass. And so from that point of view, it does make sense to actually have like something like the control plane, the Istio control plane as the policy delivery mechanism. And then you can smartly offload what belongs to the network policy to the network policy engine, such as Calico, and then whatever that needs to be implemented at the layer 7 thing, such as like, let's say, access controls, or let's say like, authentication with some IAM providers, or so on and so forth. These can actually be done at layer 7. So you can, this is something that people have found very appealing, and like, because it eliminates a lot of complexity from their point of view, and they don't really have to like, manage different points of infrastructure for that matter. So in that way, I think this is something that like people have really like, and so that is one approach that like, we are working towards with like folks from Calico and so on. And there is still a lot of work left to do in the Istio mixer, where we need to like, smartly detect and offload the policies to the network policy layer, or different like, parts of the infrastructure as a whole. And the other thing that people have liked, or like people have actually expressed interest in, is having the ability to merge different infrastructures. It's not just Kubernetes. So like, we do have a whole lot of like even internal customers who have things running on like Mesos clusters for that matter, or Spark, I mean like giant Spark clusters, or like, or bare metal like, systems where certain performance issues are, I mean, for various performance reasons. And even amongst our own customers, where they have like hybrid deployments, where they have a huge on-prem deployment, and part of it is actually on Bluemix, and the other part is actually in Bluemix local, which is actually on-prem. And they've expressed interest in the fact that we need a single control plane with which we can actually look at the entire application deployment across on-prem and and on cloud. And at the same time, we would like to impose policies at all levels, not just at layer 7, but actually policies at all levels, including layer 4, using one single control plane. And so this is where there is like, there is a big requirement, and this is something that we should definitely tackle as a whole.
Yeah, I think we're seeing a lot of the same things here at Tigera. You mentioned visibility, and I think that's one thing that we tend to talk, at least some of the policy and control, etc. But there's a lot of folks that are really having, as you said, a common pane of glass where they can see statistics and data streams coming back regarding the performance of their applications and their infrastructure across all layers of the infrastructure, both getting feedback on per URL or per endpoint throughput and latency, and where's the bottlenecks in the application flows, and also down at the network layer, and seeing who's actually talking to who, and what ports are in use, etc. So I think that visibility, and that's something that is, I'm seeing driving a lot of people, isn't just that policy control, but it's the visibility into the behavior of their application and their infrastructure, top down, across all layers of the infrastructure. And we see that as being a very compelling story for Istio and network policy together in Kubernetes. The other one that I think is intriguing again, and we hear a lot about, is hybrid. And I think one of the advantages of the way that the cloud native orchestrators have moved is that by assuming basic IP connectivity is the norm in a cloud native environment, instead of very complex overlays or fabric specific constructs that require your network to do unnatural acts to get between, say, two different types of clusters. And if the assumption is connectivity is just IP connectivity, and then service layer is handled by an IP-enabled service mesh on top of it, it really does make that hybrid case much easier than it used to be in the past. At least that's what we're seeing, Shriram, is lots of folks, like you said, who have on-prem and public, or across multiple public providers, or across multiple clusters within a provider. We just see lots of hybrid use cases. That's almost a standard today. And I think one of the big things there, it's not just hybrid greenfield, but it's the reach back to legacy. You know, great, you just deployed a great new Kubernetes cluster, all your new applications are going on it, but the dirty little secret is that database in the back room running on a dedicated server, or you know, an appliance sitting somewhere, or a set of compute blades sitting doing number crunching somewhere that aren't part of that cluster, still need to be accessed and be part of the fabric. And that's where things like, I think, Istio and an IP-centric network infrastructure really makes this easier than it used to be. Would you agree?
Yes, absolutely, yes. So this being like one of the main goals of Istio is to actually, like, you know, help people look at their application deployment irrespective of the infrastructure where things are being deployed, so that they get a uniform end-to-end visibility across the space. And so it kind of, like, you know, morphs the layer boundaries, morphs the infrastructure boundaries, whether it's on-prem, off-prem, legacy or not. It's like you view the entire thing as sort of like services and applications and of different workloads. And so that way you can actually get the visibility and control that you actually want to. And so this is one of the things that we actually like constantly see. And this is one of the things that even our customers have definitely said that, like, you know, yeah, this is something that we really, really want. And it's not just greenfield workloads that, like, you know, on Kubernetes, but we do have a ton of infrastructure on legacy stuff, and this is not going to move anytime soon. And frankly, there are like workloads that are just not containerizable, and you know, those are going to stay as it is. And but then they also need to be, you know, managed in some way. And looking at, so this is viewed as one way, or like one opportunity to provide that uniform visibility across these components.
Okay. So you actually mentioned there, you know, as we've been talking about, non-containerized workloads. I think one of the things that's interesting to mention here is the deployment models for the Istio proxy. So, you know, and this is one of the things that attracted us to Istio, is the ability to deploy Istio and specifically the Istio data path in multiple different mechanisms. So there are a lot of solutions out there, and not a lot. There's other solutions out there today that are in the same space, but most of them tend to be host-centric. They tend, the service mesh endpoint tends to be shared among all workloads on the host. And you know, the Kubernetes model, for those of you who are aware of it, the Kubernetes model is more workload centric or pod centric, that everything related to a pod should be bound to that pod, and there's some benefits to that. Some are, you know, some of those benefits are that a service, you know, things like secrets and configuration that's specific to an application can all be packaged up as a single component and distributed as a single component. And I think a key one here is like I just said, is secrets. So if my service mesh is terminating TLS for me, and TLS is something we should talk about in a second, Shriram, but if my service mesh is is terminating my TLS sessions or is originating my TLS sessions. Say you're using bidirectional TLS, mutual TLS for authentication for the clients as well as the servers. If your service mesh is in the underlying host, then that means that the keys for that given pod need to be distributed on the host or all the hosts that might land that workload, versus being able to package it up within the pod and it distributes with the pod and it doesn't leave the pod's namespace. So it reduces the surface area where those secrets are exposed. So I think where I'm getting to is one of the nice features of Istio and its current data planes are that you can pack those into the pod itself, and you can automate the insertion of them into the pod, or the developer can install them in the pod. But it really allows you to package everything, including the service mesh itself, up into the application. You can still deploy it as a host level model for those, as you said, those legacy workloads, Shriram. But I think the ability to have that service mesh and all of the secrets and configuration and metadata about that service mesh for that endpoint packaged up in that pod and being able to do that efficiently, I think is really valuable. Would you agree?
Oh yeah, absolutely. I mean, that's one of the allures of Kubernetes, which is that you have a whole slew of paraphernalia that goes with the pods, the secrets, the certain permissions, and so on and so forth. They all just delivered as one single unit without me as an application having to worry about how it's being delivered, how the infrastructure is being managed, and so on. And that's one of the areas where Kubernetes shines, and we take full advantage of that. And that's how we actually, as you said, we build mutual TLS authentication in Istio, where we create these certificates, we automatically rotate these certificates, and we install these certificates on various pods, so that we automatically upgrade connections from normal plain text to mutual TLS. And mutual TLS management is a pain in the butt, because you have to keep rotating the certificates, and this is something that we do automatically. And we do this by taking advantage of all of the features in Kubernetes, where we can deliver these secrets / identities per pod on a per pod basis, and just rely on the infrastructure itself. I mean, the Kubernetes system itself to actually propagate these identities and propagate the secrets to the pod directly, without us having to tell the application developer, you have to package these certificates, you have to package these things. All of that is actually taken care of for us. That's one of the big benefits, actually.
Right, and I think it actually, you bring up a point about the developer not having to be aware of it, and it's something I sort of hit on too. But let's think about Heartbleed. For those of you who suffered through Heartbleed a while ago and may still be suffering through Heartbleed, if I wrap TLS, for example, into the application itself, that means that everyone who owns an application in the development team, or your external developers, all have to now fix, say, a vulnerability like Heartbleed in TLS. Or let's say we decide 2000-bit keys are no longer safe, and we need to roll to a different keying system. One can question if ECC is a better choice in the long term, or if it's quantum exposed, but we'll let the cryptographers deal with all those questions. But for whatever reason, if I have to change TLS and I bound it specifically into the application code, then everyone has to roll the code. Whereas if I put, say, TLS mechanics in the service mesh as part of the infrastructure, but it's still packaged with the application, then something like Heartbleed comes along, and it's literally the operations team can roll a new version of the service mesh with TLS and a new set of keys. The application never knows that change happened. You didn't have to involve the rest of the developers. But so it's almost like it's a piece of infrastructure, but it's packaged like part of the application, sort of like the best of both worlds.
Yes. I guess this brings about, this raises the point about the sidecar. That's our main delivery mechanism through which, for the service mesh as a whole. And this is where, so it's just a matter of upgrading the sidecar, and it's just a matter of changing the certificates across the pods by just rolling out a new version of the certificates. And I guess and to a point, we just do not rely on the development process to actually package these certificates or emit a common set of metrics and so on. We rely on so the advantage behind the sidecar is that it's one sidecar that we sit and we design and we make sure that we get everything right, and that's the sidecar that we actually deploy, and that will ensure that we get uniform set of metrics across the infrastructure, impose a uniform set of behavior, where let's say certain SSL ciphers have to be used when talking to other services, and these ciphers should not be used. These are things that we can actually impose at the sidecar level, and we don't need every language runtime to implement these things in the correct way, or have to worry about chasing bugs and patches across different language runtimes that they've not implemented these small features correctly. So that's one of the big benefits of the sidecar based approach that we are seeing. And so what do you think about that actually, especially the sidecar delivery model compared to standard an API gateway style model where it's everything is a hub and spoke thing, and you just deploy one big fat thing in the front, compared to a very nimble sidecar that is just sitting next to every container in the pod.
Right. I think that was, if I think about all of the cool things in Istio, the thing that attracted us, or at least myself, early on to Istio and Envoy, the data plane that is currently the main Istio data path, was the sidecar model. And it's for exactly what we've been talking about. It's preservation of keeping secrets within the application boundary or the pod boundary and deploying them as part of that. But the ability to still treat it as a independently managed piece of code. I think, so it fits much nicer with the Kubernetes deployment model. And I think there's some other, maybe not immediately obvious benefits to doing things in sidecars. If I do things in, say, an application gateway somewhere in the middle, in most cases, that application gateway is going to modify the packet in some way, shape, or form. So off the back end of the application, gateway, it's a new packet. It's a packet sourced from the IP address of the original, of the application gateway, not the original endpoint. One of the nice things about Kubernetes is everything has an address. It's unique, it's easily managed, it's very visible across the infrastructure. At any point along a Kubernetes, in most fabrics, in Kubernetes fabric, you can tell where a packet came from. Where did that message come from? What was the pod instance, etc. Having that visibility, this comes back to visibility again, is very, very useful. And there are things that have been built around the assumption that a packet travels unmolested from one endpoint to another in a Kubernetes infrastructure. If you stick middle boxes in the way, unless you do some really interesting black magic, they end up being the source of packets and the destination of packets, and you really lose a lot of visibility and some of the other benefits that exist in these kind of infrastructures. By packaging that service mesh component in the sidecar, the traffic that is departing the sidecar or the service mesh or entering the service mesh, or the end, is either entering into the service mesh or coming off the service mesh. Those endpoints for the service mesh are the same endpoints of the application instance themselves, the pods themselves. So that same visibility and all of the goodness that Kubernetes brings with it is maintained, whereas a middle box has potentially intriguing effects as far as obscuring some of that information. And I think, that brings another interesting point. Middle boxes comes to mind. So I've been asked before, well, for those of you on the session here, and it may just be me, who who are old enough to remember things like SOA and ESBs. SOAs and ESBs, enterprise service buses, you know, they were absolutely going to save the world. They looked like what we're calling service mesh today. And they had great promise, and they lasted about 18 months. And then they sort of disappeared. And I think one of the reasons for that, and Shriram, you know, feel free to weigh in, but I think one of the reasons for that was that in order to use a SOA or a enterprise service bus, you had to rewrite your code. You had to rewrite to use their APIs and everything along. Basically, you had to write your code around that SOA or ESB. Whereas today, we already have a common RPC framework. For better or for worse, it's HTTP. And that's because there were lots of middle boxes deployed that understand HTTP and really nothing else. Load balancers, firewalls, etc. So if you wanted to have communication across middle boxes, you pretty much had to put them in HTTP. So most of the application code today is already written to use HTTP or its descendants. And therefore, in order to use a service mesh that's HTTP and HTTP follow-on based, you don't have to refactor your code. You can just drop it in, and the application probably won't even know that that exists. What do you think about that?
Absolutely.
What's your thought?
I think the key point here is that, like, compared to the old ESB, the world, there is no business logic in the mesh. The mesh is just basically meant for transport. Like L7 transport and certain policies and routing stuff. There is absolutely no business logic, which means that if I want to make a change in my service and I don't know, I want to convert from gRPC to HTTP, HTTP1 or REST to gRPC and so on and so forth. I do that in my service. I can tweak the sidecar settings in order to do that for my service, and I can just ship it as part of the, into my infrastructure without having to coordinate with 100 other teams just to tell them that, hey, I'm doing some kind of a transformation, or having to add a million more test cases as people used to do in the ESB world. That kind of hugely complicates the entire thing. So it's like the mesh is completely agnostic, and it's you bring your service as long as you package a sidecar into the service, and this sidecar can talk to the mesh. Can talk to the rest of the sidecars. You're in the mesh and you will receive traffic. That's it. It's up to you to manage the traffic. It's up to you to interpret things and so on. We just treat it as plain opaque L7 payloads. Except for the HTTP protocol, as you put nicely, it's just that the universal lingua franca within the system, and which is what we actually use to impose certain sets of actions on top of these the messages or the RPC messages between services. So it really does differ in that front. Is that we draw clear boundaries as to where we interfere and where we do not, and so that is there is not much of a transformation or any kind of interference going on in terms of what happens between your services in the application.
Okay. Yeah, I think that's, so maybe this time it will be different. I hope it will be anyway. That's what we're all betting on, right? We did get one question in, and it falls back to your comments about you referred to one of the components in Istio called Mixer. And the thing is, in any good open source project, there are people with lots of opinions about the open source project, etc. And I've certainly heard from a few folks that I want this and this in Istio, but I don't want to use this component of Istio, or I want to replace this with something else. And to date, I haven't really found a problem with people doing that. If you only need one subset, Istio seems to be pretty amiable to people just turning on the bits that they need and not using the bits that they don't. So you've been working on a lot of the development path for Istio. So how do we in the Istio community feel about modularity and the ability for people to light up the features that they want and not use the features that they don't?
So that's a very good question, and this is one feedback that that we received like a month ago and so on from like some folks on Twitter and some folks from like developer advocates as such, that it looked like as though we were packaging a giant big blob of system that you have to, it's an all or nothing system, which was clearly not the case because that was not the architectural intent as such. We had designed it such that the components, the mixer, the routing component pilot, and then the authentication component, the Istio CA, can all function independently. It's just that it was not very clear in the documentation, and we had not put in enough, let's say, tuning knobs in place in order for people to switch on and switch off components and for them to work independently. And so that's actually one of the things that we're actually addressing in the upcoming release, where we've actually like added enough flags and so on, the global mesh level flags, where the whole, and we're kind of restructuring some of the tutorials as well, where the way we are planning is that we would, as an initial adopter, would actually incrementally adopt various components of Istio. So it's like slowly warming up to different aspects of Istio. So the first step would actually be just deploying the whole thing as it is, and there's absolutely no change in your infrastructure, nothing. It's just a no. The only non-visible change is that instead of using the kube proxy for load balancing across the services, all traffic will just flow through the Envoy sidecar that we actually install on all of the pods. But it's still a no-op in the sense that the behavior is just going to be the same. Then you can slowly warm up and try a hand at routing kind of stuff, A/B testing kind of rollouts, or and so on. You would can also set up like circuit breakers, rate limits, retries, just to make your end-to-end, make your system more resilient to failures. And then once you're more comfortable, and once you're comfortable with the fact that system is not breaking anything, everything is just working, you can start playing around with the mixer, where you can actually go and add in policies, simple things starting with rate limits or quotas, and then or network policies which get offloaded into the system automatically. And once you have more confidence, then you can actually turn on the mixer for the entire mesh completely, such that or for any given pair of services. So you can decide to turn on the mixer for individual services or for all of these services. And then once you're comfortable with this entire operation, you can decide to turn on mutual TLS authentication, which is sort of it's like a binary flag. Once you turn it on, then it just basically turns the entire communication within the mesh into full mutual TLS communication. And once let's say you're familiar with, you get more comfortable with that, then you get into more deeper aspects of Istio, where you start writing more adapters to send metrics to your custom, to your own backend, so that you can actually get rid of any of the monitoring agents that you actually installed that scrape a whole bunch of things, but you can just scrape these metrics via the sidecars itself, and and so on. So we are trying to address this feedback, and it's good that we actually got this feedback. The point is that we've designed it from from the beginning to be incremental and modular. It's just that it did not come out that clearly in the docs and the tutorials, and so we've kind of making it much more explicit and clear.
So Shriram, you're saying, surprise, surprise, an open source project has a deficiency in its documentation.
Well, yes, given that the documentation was written in, but yeah, that is certainly true. But I'm really very happy with the state of our documentation, at least when the first 0.1 release, because a whole bunch of people on Twitter and so on, they said the documentation is in good shape for something that just came out as it is.
Yeah.
Not this. So that is one of the things that I was really proud of the entire team, like Google and IBM inclusive, and one of the iron rules was that if you write the code, you have to document it. It's you cannot punt on somebody else and some technical writer to come and document. We can clean it up and smooth out the language, but you have to document the feature. And so that behavior really got into everybody else's mind, and so people basically started doing that. Any new feature that gets added, there will be documentation PR as well, and so that kind of kept things in sync. But yes, there is still gaps, so it's a never-ending task, documentation. I did hear that you guys were starting to offer or planning to offer Istio training. What's the deal with that?
So yeah, well, thanks. So Tigera is offering a set of training around what we're calling application connectivity for Kubernetes. And one of the modules of that training that we're offering is around Istio and helping people, helping people get up to speed with Istio. We've got a lot of people they've been hearing the buzz. They're looking at trying to get it stood up and there might be one or two folks who really get it, but they're looking for training for other people in their organization are going to have to operate or develop to this environment. So we're going to be offering a training package on Istio and other aspects of Kubernetes networking, but reach out to us at tigera.io and we'd be happy to discuss Istio training with folks who are interested. Anything else, Shriram?
Well, so what kind of this is always out of curiosity. So what kind of deployments do you actually see in the wild where today, what do people do with their services and that are spread across multiple infrastructures? Obviously, you do deal with folks who are actually have Mesos and Cloud Foundry and or on-prem and so on.
Sure.
So how do they actually deal with these things? And do they have giant API management solutions and F5s and so on and so forth? And so how do they actually even devise these policies and so on and so forth? And network policies across these infrastructures. Is there a pattern that people follow?
So the network policy, I think, is maybe a little bit further along. We've been doing it a little bit longer. So we do have folks that are doing network policy across multiple orchestrations or multiple platforms. There really hasn't, until Istio came around, there really hasn't been a good mechanism to do that that is not completely wedded to a given orchestrator. So for example, there are people that have pretty much everything you mentioned. They have hardware-based appliances, they have API servers, they have all sorts of load balancing, other platforms that are probably, that are either very general, based on simple 5 tuples or rules that you program into them independently of everything else, or very much tied to a given orchestrator like kubeproxy. So what people have been doing when they've been trying to do this is, use things like they'll use an F5 load balancer and then they'll stick a kubeproxy in front of that to do the service discovery and fan out capability, and they'll do east-west differently than north-south. And the message we're getting from everyone is that they really want that to stop and to simplify that. And one other thing they really want is they want to do the same, potentially the same technology for both north-south and east-west. And north-south can be inter-cloud or it can be from entirely external. So I think we're early days, but we're definitely seeing a requirement from the industry to have a single fabric for doing this. And the key is going to be making sure that policies that are used to drive this, and one we hear a lot about, especially for cluster inter-data center, is policies to drive TLS and mutual TLS. If it's going to cross from my private cloud to my public cloud, it's got to be encrypted, either IPsec or MTLS or something along those lines. And having a policy-driven way of doing that is something that everyone is asking for, and not just going to flow into lots of other things that people want to have a common framework to do this. It doesn't really exist yet, and I think that's one of the things that's driving the excitement around Istio. Is it looks like Istio might be the vehicle that will